So we like to use liters for volume. A liter is a cubic decimeter. A decimeter is a tenth of a meter. Tenth of a meter is 10 centimeters. So 10 centimeters on a side cubed gives us 1 liter. For smaller volumes, we can use a milliliter. A milliliter is a cubic centimeter. So centimeter cubed is a milliliter. The metric unit for the SI unit for volume is a cubic meter. Cubic meter would have a volume of 1,000 liters. So cubic meter would be a kiloliter. Since this country still uses the old-fashioned English units, we need to be able to convert between the English units and the metric system. And if we know one of these conversions from each of the column, then we should do pretty much any metric English conversions. So a meter is slightly longer than a yard. A meter is 1.094 yards. An inch is defined to be 2.54 centimeters. So this is an exact quantity. This has unlimited significant digits to it. It's perfect precision. For the meter conversion to yards, 1.094 yards, there are additional digits, decimal places that can go with this number. But for 2.54 centimeters equals an inch, all the additional decimal places are zeros. 2.54, 0, 0, 0, 0, etc. 1 foot is 0.3048 meters. And a mile is 1.609 kilometers. So we don't need to know all these. I can convert between miles and kilometers using 2.54 centimeters equals 1 inch. For mass, a kilogram is approximately 2.2 pounds. More precisely, a kilogram is 2.205 pounds. A pound is 453.6 grams. And the number of significant digits that you use depends on your need. So if you only need 3 significant digits, a pound is 454 grams. So you can pick the number of significant digits that is necessary for your project at the time. An ounce is 28.35 grams. For volume, a liter is slightly more than a quart. A liter is 1.06 quarts. A gallon is 3.785 liters. A cup is 236.6 milliliters. And a quart is 946 milliliters. One of our first properties that we look at is the property of density. In fluid systems, some things sink and other things float to the top. So if we have salad dressing, we shake it up and make it into a emulsion, we let it set, and it separates out. And the oil always floats to the top and the vinegar always floats to the bottom. When we flip the bottle upside down so the vinegar is on top, it will fall to the bottom. The property that determines which material floats to the top and which material sinks to the bottom in fluid systems is density. High density objects sink, low density objects float. So if we look at the oil and the vinegar, that means we're going to say that the vinegar is higher density and the oil is lower density. We define density as mass per volume. So density we represent with lowercase d, mass is represented with lowercase m, and V is represented with a capital V. So we see we're using m here for mass, but just before I said m was meters. Well, for the metric units, when we see that m, there's going to be a number in front of it. So if we have 35 m, that means the m is a unit, and it would be meters. If we have d equals m over v, there's no numbers. There's an equation. There's an equal sign. That means the m is a property, not a unit. And as a property, we use m to represent mass. So for units of density, we like to use grams per milliliter or grams per cubic centimeter for solids and liquids. These are not the SI units. We only have to switch to SI if we're converting between density and other properties. Because when we're converting between different properties, besides our mass and volume right here, SI units guarantee that if we use SI units in an equation, we know that we're going to get SI units out. For gases are much less dense than solids and liquids. So we like a different density unit for gases. We like to use grams per liter. We have one density unit, one density value that we want to remember, which is water. We're going to learn water. So water at 4 degrees Celsius, or approximately 4 degrees Celsius, has a density of 1.00 grams per milliliter. This 1 gram per milliliter is also equivalent to kilograms per liter. So grams per milliliter always scales directly to kilograms per liter with the same numerical value. So the density of water is 1 gram per milliliter. It's also 1 kilogram per liter. Now we generally don't worry much about this 4 degrees Celsius. The density of water is exactly 1 at temperature very close to 4 degrees Celsius. This is the most dense that water is. As we increase the temperature, the density decreases, and as we decrease the temperature approaching freezing, density also decreases. But generally we can get away with just using 1 gram per milliliter for our density. If we need more precision at a different temperature, we can look up the density of water at that temperature. Our properties are also either intensive or extensive properties, depending on whether it varies with the amount of substance present. Intensive properties do not depend upon amount of substance present. Extensive properties depend upon how much of the material is present. So mass and volume are obviously both extensive properties. They depend upon how much material is present. But once we do mass divided by volume to give us density, we have created an intensive property which does not depend upon how much material is present. So density is an intensive property. It's the same whether we're measuring a couple drops of water or a swimming pool of water. The density of liquids and solids vary slightly with temperature. We can generally ignore that unless we are doing some very precise work. The density of gases varies greatly with temperature, and this cannot be ignored. We will study gases all by themselves. So this is just some examples of density. We're not going to memorize anything here except for water. We have vegetable oils 0.79, acetic acid 1.05. Acetic acid is the main ingredient in vinegar, water being the other ingredient in vinegar, and water is 1. So vinegar is going to be somewhere between 1 and 1.05, which is obviously heavier than 0.79, which is why vinegar sinks to the bottom and vegetable oil floats to the top. Gold is 18.9, relatively heavy, and we have some that go significantly higher than gold also. So density is mass divided by volume. That means we can use density to convert between volume and mass. And of course, we can use volume and mass to calculate density. So if we have, let's see here, a block measuring 2 times 3 times 1.5 centimeters, mass of 8.1, what's the density of the block? Well, we have 8.1 grams. We need to get the volume. Volume of a rectangular block is going to be length times width times height. We calculate that volume to be 9 cubic centimeters. So we have our mass 8.1 divided by volume of 9. That will give us 0.9 grams per cubic centimeter. And a cubic centimeter is 1 milliliter. So we mentioned that before. So we can convert also between grams per cubic centimeter and grams per milliliter as necessary. So if we have volume of ice that weighs 3.75 grams, we know the density of ice is 0.917 grams per cubic centimeter. We want to know the volume of the ice. So we take our density as mass divided by volume, solve for volume. When we solve for volume, we end up with mass divided by density. We can also get this by looking at the units of mass and density. We know that for density to give us volume as a numerator, it has to be in the denominator of the denominator. Remember, it's in the denominator of density. So to get it in the numerator, the density has to be in the denominator. So we have cubic centimeters is in the denominator of the denominator, which gives us it in the numerator. So we do mass divided by density, and we end up with 4.09 cubic centimeters. And on this bottom line also, so this shows us another way that we can do this. So if we divide by something, it's equivalent to multiplying by its inverse. So if we're dividing by density, density is 0.917 grams per cubic centimeter. So instead of dividing by it, we can go to multiplication by the inverse. The inverse is 1 over the 0.917. So it's 0.917 grams per cubic centimeter. That means it's 0.917 grams per 1 cubic centimeter. So with the inverse would be the 1 cubic centimeter on top over the 0.917 grams. This way it makes it a little bit easier to see that we got grams divided by grams, leaving us with cubic centimeters as the unit of the answer. So if we have a piece of zinc weighing with a volume of 12.3 milliliters, we know the density is 7.14 grams per milliliter. What's the mass of the zinc? So we're going to take our density as mass divided by volume, solve for mass. We get mass as density times volume. Just making sure our units are matching, we get 12.3 milliliters times 7.14 grams per milliliter. Milliliters cancel, we're left with 87.8 grams. And we'll go on to